Alright, so this will be our notes on plate boundaries. We're going to kind of start tying the science in now with the exploration part we've been talking about, and we're going to start that with something called plate tectonics, and then we're going to really look at these plate boundaries, and you're going to make some models. So really these plate boundaries are based on this idea of plate tectonics. And this was something they kind of understood, for a long time, but really it wasn't until the 20th century that they really started understanding what the Earth was made of on the crust and what was inside the Earth, and they kind of had ideas before that, but it really came into clear view in the last 100 years, which really isn't that long ago. And so these plate boundaries work off this idea that the Earth's crust is made up of plates. So we know the Earth, if we were going to draw a picture of the Earth, okay, and if you just imagine an apple, just the skin of the apple is the crust. And then inside of that, in the center, is the core, and there can be an inner core and an outer core, right? This would be inner. Then you have something called the mantle. And you can even take the crust, divide it into the upper part, the lithosphere, and then the bottom part of the crust. And the upper part of the mantle is the asthenosphere. And there's a lot more words we can add to this. Now the crust is solid. This mantle is like a liquid solid mix at points, but mostly magma. And then the outer core and inner core, iron, solids, and so on. Extreme temperatures, and we're not going to go into that too much because you've probably already had geology and you probably already understand that. But the thing we want to look at is the idea of plate boundaries. And I'm going to show you these crusts though, or the plates, I'm sorry. So the Earth's crust is made up of plates, and we kind of realize that here because wherever there are boundaries, there's going to be tectonic activity, and that means earthquakes, volcanoes, and subduction. That's where one plate goes underneath another. But let's look at these pictures here. I got a picture of these plate boundaries. Let's see if I can find that quickly. No, we're getting there. So here's these plate boundaries, and we're going to actually close this part, come back to it. Okay, so here you see North America, and most of Central America is on a plate called the North American plate. And wherever these solid lines are, that's the plate. And here we have the Caribbean plate, and we kind of learned where the Caribbean Sea. We have this little small here, the Cocos plate. Here is Juan de Fuca plate, really small. Filipino. Here's the Pacific plate, really a large one. And if we went over here, we'd see, let's move this over, the Arabian plate, African plate, and some of them coincide, or not some of them, a lot of them coincide with the continents that are on them. Here's Eurasian plate, but you can also see arrows on here, and that tells you the direction of each plate. So if we're looking at the Eurasian plate and this North American plate, they're moving away from each other because the arrows are saying that what direction they're moving. And then this Caribbean plate and this Cocos plate moving towards each other, and then this Pacific plate, North American plate are actually sliding by each other. And here we are in Alaska. We actually have the Pacific plate and the North American plate running into each other. One's subducting or going underneath the other because something has to happen. They either have to go underneath each other or form mountains. And here we're kind of seeing both, but there really is subduction that's forming those island chains there. But that's kind of the idea. Like this is the crust, the outer part of the Earth, and it's not just one solid piece, but instead it's made up of all these different plates that are moving. Okay, we're not going to go into too much why they're moving, but you can ask questions, I guess, about that. Okay, so plate boundary is a section where two plates meet. Okay, and they can be coming together. They can be moving apart. And then they can be going side by side. And sometimes they can be doing a little bit of side by side and coming together and side by side and moving apart, but they usually name it according to the main motion that they see. And wherever this is happening, like I said before, you're going to see earthquakes, you're going to see volcanoes and subduction. I think there was just an earthquake in Italy, and if we went back to the map, we would see most likely there is some kind of plate boundary there. Okay, so what we want to do though is we want to look at these three types. And you might say, well, why are we even doing this? Well, this idea of the Earth's plates first came from the HMS Challenger. That's where this idea. So we kind of talked about how exploration at first was trade and expanding empires and so on, but then the Challenger came on and made it just about science. And they discovered something because they had gone out and they were measuring measuring the ocean floor and seeing what it was like. And they had this idea before they started measuring it and really had the ability to do it, that it was mostly flat. Well, that idea is completely wrong. Okay, it's not mostly flat. In fact, it has mountain chains, it has valleys, and it does have some flat parts called abyssal plains, and it has something called continental margin and so on, and we're going to kind of learn some of those as well. But the Challenger is the one that really started opening this idea that this sea floor isn't just flat, and there's mountain chains. And how did they get down there? Well, these mountain chains got down there by this idea of plate tectonics. And when plates move, they do things. They crash into each other and form mountains. They move apart and they can form mountains that way. They can be going side by side and so on. So that formed the different parts of the ocean. And within the ocean, there is something. You're going to have to make sure you leave room because we're going to take notes on this too. But it's something called the mid-ocean ridge. And that's just a mountain chain in the ocean. I'm going to show you a picture in a minute. They had thought it was flat, and then they start measuring the depths of the ocean and seeing it was a lot deeper than they thought. But also, it wasn't just flat, it was mountains down there. So then if we look at this picture, where are we? There we go. So here, you see the little blinking parts, and the color is talking about the different elevations. And you can kind of see in the middle here of the ocean is this white part, and that's what they call the mid-ocean ridge. I'm not sure I can color on it. I probably can't. So I won't be able to do that. But all those blinking parts, those are little mountain chains, and then off to the side you have some that form, and these are all these white parts are like higher spots on the ocean. And when the Challenger is going all through the ocean, they're starting to realize that there's these really deep spots, there's these spots that aren't so deep, there's mountains down there, and so on. And this is where they really discovered the mid-ocean ridge. It's really started thinking about it. Okay, and then the next question comes is, well, how did it get there? You know, and then science just kind of worked on that. And if we look at these, I'm going to go back to the notes here. If we look at this and how this works, what type of boundaries do we have and what do they form? And that's what we're going to finish up with here. So I'm going to erase some of this stuff. Hopefully you got it. Pause the notes or go back if you didn't quite get this. Okay, so we go down. I'm going to erase that too. We'll actually just clear it. Okay, so there's three types of these boundaries, and that form the mid-ocean ridge, and that form things on the Earth that we see. Okay, so there is really, let's show you all these. So the three types are divergent, convergent, and transform. The first two are the ones we're really going to worry about for our mid-ocean ridge, and parts of the ocean are divergent and convergent. You probably kind of know something's diverging, plates are moving apart. And a lot of these form new ocean crust. And if you're not aware of this, and you've probably had geology as well, the crust can be oceanic and it can be continental. Okay, and these form in different ways and are made up of different types of minerals and rocks that form them. Okay, oceanic is much thinner and denser. Okay, and that causes something when they come together. Divergent, they're just going apart. So if we had, a plate like this, we had a plate like this, and they're going apart. And we know this is the crust, right? So in here we have the mantle, and in the mantle is magma. And that magma, then if there's an opening and there's pressure under here, it's going to push down or push out, and it's going to form mountains here. So as these plates are getting pushed apart, magma comes out and forms this, mountain chain right here, and that's the mid-ocean ridge. Okay, so wherever those plates are moving apart, they're divergent. They're forming oceanic crust under the water if that's occurring, and they form something called the mid-ocean ridge and also the mid-ocean rise. Ridge is much steeper, so they call it a ridge. Rise is much more gentle sloping. Okay, and it really depends on how fast the plates are moving and other things. Okay, and where they're forming. And this idea of seafloor spreading, and that's kind of what's happening here. Plates are moving apart, and the seafloor is spreading and forming new oceanic crust as it does so. And they kind of recognized, they saw the mid-ocean ridge first in the HMS Challenger. They then came back later on, I think 1960s, and they had a ship that was kind of named after this one. It was called not the Global, Glomar Challenger. And it took a lot of data, and it actually took samples of this crust in various spots. So it takes sample 1 right here, and just take a sample right here. It takes sample 2 right here, take sample 3 right here, and just see things about it. What was it made up of? How old was it? This is Glomar now. HMS couldn't do that, but this Glomar actually had a drill. They could drill down into the crust, take some out, and see how old it was. Well, they found out that this first piece closest to the mid-ocean ridge was youngest, and as they moved away from this mid-ocean ridge, the crust got older. Well, if it formed at the same time, it should be all the same age. But if the one closer to the mid-ocean ridge, or where it's forming, is younger, that must have formed after the others. And it kind of gave them this idea of seafloor spreading. This didn't come from the HMS Challenger. This came from the Glomar Challenger. Okay. But that's a divergent boundary. Plates are moving apart. As they do, magma forces its way up through and then forms new crust. And it can form ridges, mountain chains. It can form rises, which are much gradual mountain chains, and it just forms the crust as this process occurs. That's a divergent plate boundary. And then you have a convergent plate boundary. This is one where plates are moving together. So I'm going to erase this. Hopefully you got enough room. So this is convergent. This is where plates are moving together. So you have one this way, one this way, okay? And this can be lots of different things. It can be oceanic, it can be continental, and these form mountain ranges and trenches, okay? They form mountain ranges when they're the same density. They're equal. So when these come together, if they're the equal density, equal strength, then instead of when they hit, they're going to kind of deform, and then they're going to kind of crumple up as they continue to come together, and you're going to see mountain chains formed, right? And that's where they're the same. If they're different density, I'll leave some room because we got one more thing after this. If they're different density, and that's the true if it's oceanic, this one's going to come this way. This oceanic is thicker, less dense, but the more dense is what's going to happen is it's going to go underneath. So then this crust starts bending, and instead of forming these mountain chains, one goes underneath the other. Okay, and that's going to be oceanic going underneath continental. And right here, this is where this forms this trench when that happens. And they also call this a subduction zone. One plate goes underneath the other. So that's a convergent boundary. The last one we have, and I'm going to erase this, so be ready. Stop it if you want to, if you're not done. The last one is a transform boundary. We're not going to worry about this one as much. This is where plates are moving side by side, and you have earthquakes here. And really, I'll show you a picture of this one. Where is it? So, no, well, here's your subduction. You see lithosphere. This one's going underneath. This is oceanic crust. Here's continental, much thicker. And even at these convergent, you also have volcanoes and such, and we'll talk more about that. Let's see if we can find this one. Here is a transform boundary. One piece of crust moving south, the other one moving north, and they're just moving side by side, and lots of earthquakes there. And if you go to California, you'll see that occurring there. That's where the earthquakes come from. There's not a lot of these in the world. Many of them really come from this, because this has earthquakes as well. Okay. So that's kind of our notes on boundaries. There's three types: transform, convergent, and divergent. We're going to talk a little bit about these. We're going to make some models of them. But that's your notes. Let me know if you have any questions. Make sure you annotate these and turn them in.